Today I want to talk about this issue. This issue means title is best team with conflict. The key point is for the edge, the basket team, and not along the conflict. The conflict is means if the candidate one younger player has a strictly higher score than an older player, that is conflict. That is cannot consistent team. So the input is two array. One array is score and another array is ages. And when I get this issue, and I need to display graph help me understanding, and I will to draw. So that means we have a array. The array, one array is age, another array is score. Every element has a corresponding relationship. So the first step is I will, according the edge, to sort this this array. This array can be consistent as a one array to consider, and the whole of one array can be sorted by ages. After sorted, that means after sorted array, and right now after sorted, right now the age is a strictly is ascending order, and the score is maybe different, has a different has a random order. So that's that one. The problem converge to I need to find a LIS problem, and is longest increasing. I will find a longest increasing sequence in the score. That means that is DP problem. For example, I start this this point, and from this point, maybe I need to find this longest, and for this point, B point as a start point, and I need to find the longest subsequence. This subsequence is a candidate, and also subsequence is a candidate too, and until I found the end precision. So from the from this graph, and I can convert this problem as a LIS problem. The difference is I need to use the object to instead of the previous array to solve this LIS problem. And the LIS definition is longest increasing subsequence. And for our problem is longest sum increasing subsequence. For the longest increasing subsequence, that means I have a subsequence, and right now I visit the current I position, and I need to traverse the previous position J, and to compare the previous J value and the I value. If J less than the general formula is if J is less than the I, then the I will update the value is DPI, current DPI, and for the previous J plus value plus the current one. And the max or minimum, it depends the requirement of the problem. For our current problem, I can define the end of this I, end of this I sum score, the I operation should the sum score. So for the DPI will be DPI equals the general problem is DPG plus current score, DPI score. Score I, and for J less than the I operation is previous operation T, and ST score current I, that means the I operation edge more than the J operation edge. So the younger player should the score will be less than the older player score. So I can write the code. And so first I need to get the array size and use the vector to sort it. Sort it is I use a pair. Pair is include the adjacent score. Players, candidates, here right here, and for verse 8, to add the current operation into vector. Pair is a first one is ages. Coding age is I, and the scores. Then I will sort this pair. Sort the vector begin and after sort, and I will do the define DP I will use a DP to define it, to traverse this use LIS solution to solve this problem. And I will be also second one is for every J operation, previous operation. J equals I, and the J I, J plus plus. When I encounter the previous operation, edge is less than the current operation, and I will update the current DP value. DP value. DP is a auto array, and the player second, player J. So every player J, the first will be less than the edge, less than the I, and right now only consider the score elements. I second, then IDP will be updated as a DPI and DPJ. Right now that is matched candidate. For matched candidate, I will add the current. I will add the current score. The first one in the first for loop, and I need to set the current DP initial value. Initial value means if previous operation no match the element, so that means I can use only this one as a team member. So I can set the initial value as its the score, the current score. For the last step, to traverse the DP, every element of DP, because every element has possible as a maximum score. And DP yes, X DP will be into I, and I will define the array DP. DP is n value, n value. So because we have no out boundary, I is our boundary, J is our boundary, not any our boundary scenario. So we don't need to set any inspiration. Choose. Not any out boundary or boundary scenario. So I can try that. Size is n. I can try more. And so it's okay. I passed all the test case, and for this problem, and we can also use DFS. DFS is from the DP formula to convert the DFS. The basic idea is this DP means from the bigger problem DPI and convert to DPJ. DPJ is a sub problem. And next video I will try to use the DP formula to convert as DFS with recursion solution. Hope that video help for you. Thanks.